Hey everyone, in this video today we are going to solve the today's problem for the LeetCode. So that is find the safest path in the grid. Okay, so what does the problem statement say? It says we have given a grid of size n cross n. Grid of R c equals to 1 means it contains a thief, empty cell means it's a 0, means if there is a 1 we have a thief there, 0 means nothing. Okay, then we are initially at 0 comma 0 and we can move to any adjacent cell in the grid. Okay, and then there is a safeness factor of a path of the grid is the minimum Manhattan distance from any cell in the path to any thief in the grid. Okay, so basically if there is any path from 0 comma 0 to let's say n minus 1 comma n minus 1, then out of all these paths, right, the minimum of all these, right, x1 x2 till xn, right, that will be your safeness factor. Okay, and what do we have to return the maximum safeness factor. This is what we have to return. Okay, then okay, so let's see. So mm, initially it looks like if we from each node, if we traverse to the end and we calculate the right the distance of each node from the node, and in the path we find the maximum that it can work. But what will be the time complexity? Let's say if we traverse right each path, that will be n cross n, right, because I comma j pair. Then for each cell we find the minimum Manhattan distance, that will be like a BFS again, n cross n. So it will become n raised to power 5. Okay, this will not work. So what we do, what if we pre-calculate the distances? Okay, distance means basically for each cell, what is minimum Manhattan distance from any thief? Okay, Manhattan distance from any thief. Okay, then once we have this minimum distance, right, then for all the paths we have to find a path which has this we have to maximize the safeness factor basically, right? We always pick the, let's say if we become right after finding the distance, it becomes right 2 1 0 3 2 1 0 1 4, right? 4 cannot be possible, right? 2 also not possible, so we do 1 1 say 2. Okay, then we greedily pick like this, then this, and then this, right? How can we do that? Okay, then I think it's like standard Dijkstra's. We initially push 2's to the priority queue, then we push all of its neighbor 1 comma 1 comma 2 to the priority queue. We pick the one with the maximum. Again we push its neighbors to the priority queue, that is we push 1 comma 1. We don't push the already visited 1 comma 1 comma, right? Okay, we cannot traverse diagonally actually. So initially we push 1 comma 1. This will not be a path. Initially we push 1 comma 1, then from this one we push 2 comma 0. Okay, so it becomes 2 initially, then it becomes right 1 comma 1, then we pick this one, and we for this one we pick 0 to 1. Now in the priority queue it becomes sorted, it becomes 2 comma 1 comma 0. So minimum is 1, right? Then we pick the 2, we again push both 1 comma 1, right, these two, this one and this one. So it becomes again right 1 comma 1 comma 1 comma 0. So then finally we reach the destination road, right? But minimum Manhattan distance will become 1, right? So safeness factor will become 1. Okay, let's see in this example what it is. Uh, okay, let's say first we pre-calculate the Manhattan distance, right? So for this node it will become 1 1 1, right? 2 2 2 2 and 2. Then which path we select according to our Dijkstra, we first push this one, right, 2 comma 2, then we push all its neighbors, but highest will be this one at the top. We will take the Max-Heap while using the Dijkstra algorithm, then we push this one, this one, this one, so answer will become 2. Okay, that is what we are aware. Okay, so we have to do two things here, right? First is prepare the distance, right? Prepare the distance array. So we convert this grid problem into first by preparing the distance of each. Then second, what we do, we apply Dijkstra's algorithm. So this will give us the answer. Then in the end, we return the maximum safeness factor that we can have. Okay. Then how to calculate this distance efficiently? We can use a BFS for it. If we use the DFS, then the time complexity will become right I comma j we traverse n square. Then for each we again traverse the entire array. It becomes n square cross n square, which will be like n raised to power 4. So we are not going to use it. So what if we use the BFS? We push right. We initially push all the nodes with thief, right? All the nodes will thief in the queue. So let's say for the above problem, I push 0 comma what 0 comma 2 I push. And what is the initially and since we need to maintain the Manhattan distance, so let's say I'll put 0 comma 2 comma 0 initially. Okay, then the next step will be its neighbors, that is this one, that is this one and this one. So then I update both of its neighbors, right? 0 comma 1 comma 1 I update, and the other thing which is 1 comma 2 comma 1, again I push this both of them to queue. Now let's say if there are multiple things. Let's say there is a thief here. So let's say there is a thief here, right? In this case, what happens, right? We right, when we run BFS for this one, we push this, right? But when this particular node comes, right, it checks the Manhattan distance again for this and becomes right 1. So we, if it's less than the previous one, right, we again push the same node again to the BFS. So the max time complexity for BFS will be n cross n square, right? Okay. So once we run the BFS, we have the distance, right? Then we can easily get the distance in of1, right? For any cells, let's say I comma j, we can get the Manhattan distance value in of1. Okay, so this is the BFS part. Then the second part is Dijkstra's algorithm. We initially push right 0 comma 0 comma whatever is the value of the, let's say, Manhattan distance xi, right? Then what do we do? This is the for the node 0 we put. The next will be its neighbors, again the same techniques. Neighbors will be 0 comma 1 whatever its value, and we update this one. Update this with what? The maximum safeness factor till now, that is minimum of x1 comma x2, right? Because if in an entire path you, let's say, x1 x2 till xn, the safeness factor will be minimum of all of these. Okay, yeah. In Dijkstra's we keep a visited so that we don't again traverse to the same area. Let's say we are at this position, right? I initially push this one, I push, then I push this one, then again I don't want to push this one, right? Because the distance will be less than the current, but I don't want to push it again. So then we keep track of a visitor so that we don't stuck in a loop. Okay. So what will be the time complexity for Dijkstra's algorithm? We use a Max-Heap here. So first is since we write our number of edges will be right n cross n, because we are making the use of entire grid basically, right? So it becomes n cross n now. Log of, right, what is the time complexity of insertion into the Max-Heap, that is log n, right? And what is the total number of v vertices vi, that is n cross n. So it becomes n cross n, that is what, say 2 times n square log of, and so we can essentially say it is n square log n plus n square for BFS. So this is the final time complexity. Okay, so now you understand we are going to solve the problem in two parts. One, BFS for distance. Two, Dijkstra's. Yeah. Okay, so let's see the code part. So we have already seen there are two parts. First is running a BFS to maintain the distance array, right? And the second part to the question will be to run the Dijkstra's algorithm, right? Part two will be Dijkstra's algorithm. Okay, so we define n equals to grid dot size. We need a queue, right? So right, queue we will do a pair. We have to define the pair as well. Queue equals to, what do we say, new array dq, right? We have to define the pair class pair intx comma nty, right? Pair, if I give it two values intx comma nty, right? This is the default construction, right? This dot x equals to x and this dot y equals to y. Keep correcting me if I make some mistake. So then we loop for the I less than what, n I plus plus, then nt j equals to 0, j less than n, j plus plus, we leave loop and we add to the, if there is a thief, right? If grid of I comma j, okay, grid of get I dot get j, since it's a list equals to 1, we add this to the q dot add new pair, right? Pair current is I comma j, we add this one to the queue. Then we need to run the BFS part, right? So we do while q dot size greater than 0, we need to initialize the distance as well. So we say anti distance equals to new anti dot n cross n. Since it's from 0 to n minus 1, this is enough. Initially the all distance values are 0, but we need to maximize these values, right? So we do for anti I equals to 0 other than ni plus plus, because we take the minimum, so we cannot initialize to 0, then it becomes 0. There is dot fill distance of I, what can be the maximum value, right? So the maximum value can be, it cannot be more than, right, the x plus y, and x plus y can be maximum if we are on the diagonal basically, right? So let's say the this is the 400, right? So it cannot be, like, you can take 800 or something. Let's, to be safer side, we take 1000, but cannot be more than 800, I guess 800 or 400. Okay, so while not the current size, what do we do? So what are the directions we have, right? We need directions equals to new, right, equals to what? We can do 0 comma 1, right? We can move to the bottom, then we can move to the next, right, we can move to the left, and we can move to the top. So this is becomes our directions, right? So pair current equals to what? Q dot remove. This removes and gives us the current element. So for anti, right, directions out of what? Directions next, what next become current dot x plus what? D of 0, right? Next y, what will become current dot y plus direction of 1. So what do we do, right? If it's valid, if nx greater than equals to 0 and nx what? Nx less than n, and ny greater than equals to 0 and then ny less than n, if it's valid, right? And Manhattan distance is less than the previous one. Just a second. Okay, so if the distance of, right, the Manhattan distance, right, if the distance of current is what? Greater than distance of, right, what? Current dot x, current dot y plus 1, right? It means the distance that we already had to the new position is greater than 1 plus this one, right? So then we update it basically. So then what do we do? Distance of next comma and y equals to what? What it will become? It will become 1 plus distance of current dot x, current dot y, and we add it to the q dot add. What do we add? Then this pair, right? We already have a new pair nx comma ny. Okay, so this will be a BFS. I think it's right. Okay. Then now we have the Dijkstra, right? We can find any Manhattan distance for any cell in the O front time complexity. So next is we'll use the priority queue. Then priority, we'll implement the Dijkstras now. Priority queue. Now what will be the state, right? At any point for a node, what do we need? We need I comma j current safety, right? So we need a tuple here. So we'll do a tuple tuple class tuple intx, right? Intx y and d we say for distance. Then we set tuple intx inty and d we say this dot x equals to x, this dot y equals to y, this dot equals to d we say, right? Okay. So CTUPL, right? Tuple priority queue PQ equals to what? New priority queue. So now by default the priority queue in Java is main heap, and we need the max heap here, right? So we need a comparator basically. So let's say we have two tuples A B. So what will be our comparator? B dot distance, right? B dot distance minus A dot distance, right? If the second distance of second minus Manhattan safety value of current is greater, right? That means it's positive. So yeah. Okay, so what do we do? We initially have to put something, right? PQ dot add. We can do add or offer anything. I think offer is safe because it handles null values or something. So we do PQ dot offer. We write, what do we say? 0 comma 0 comma. What is our current Manhattan distance at this one, right? From any thief. This one. Okay. Now while PQ dot size greater than 0, we also need a visited in this case so that we don't keep visiting again and again. Right? And visited boolean we can make it. Boolean visited. Just to know boolean size and, right. Initially all values should be false. What's the default in boolean? Okay, let's see. Tuple current equals to what? Priority q dot, right? We remove the top element and we get it. Peak is also there, and for int d star in directions, right, we can do for all directions. And if, right, if our current, if current dot x equals to n minus 1 and current dot y equals to n minus 1, right, we have reached to the end, we return the current safety basically. Otherwise, right, what will be the next position again? Next position equals to same, right? Current dot x plus what? D of 0. What will be the ny? Current dot y plus d of 1. So we check if it's valid, right? If nx greater than equals to 0 and then ny greater than equals to 0, nx what less than n, and ny less than n, right? And it's not visited of n and y. Okay, next, it's not visited. Hmm. Okay, so in this case, what we are going to do, we are going to add it to the priority queue. These are its next neighbors. If it's not already visited, we do priority queue dot offer. We do nx, ny, and what will be the safety? That is maximum, right? Maximum till now. And we need to find the maximum of the entire path. So in a path, what will be the maximum safety? That is minimum of all, right? Minimum Manhattan distance. So we do current dot the common distance of next, right? We are on the next one. This is okay. We remove, we do things seems right, and then we return zero or something because we always reach to the end. So this will never happen. Seems right. Did we miss anything? Okay, illegal pair and priority queue dot offer. Sorry, new tuple, right? We make a new tuple. I'm habitual in C++, so I do sometimes make these mistakes. I think this is also wrong, right? Then new tuple. Okay. This is difficult. Like once we get the conceptual part, then it's easy. So just boolean visited new boolean, and what's the problem? Boolean cannot be converted to boolean. Okay. So it will be boolean. Then we see that's a distance, right? We use dist. Okay. Hey, hope this works. Let's see. Okay, TLE. Where did we get the TLE? If right, which part we get the TLA? Okay, we haven't marked it visited, right? Visited of nx and y, right? This one is visited now. We'll make it true, and we also need to make the visited of 0, 0 equals to true. Do it. It's okay. Output is 1000. Second 1000. Second 1000. Why? Hmm. Did we update it? Yes, we did. Nx greater than nx less than y, and my condition seems true. It's the current distance, right? If current distance greater than distance of current dot x. Did we initialize this initially for all of these, right? I think for all thieves initially the distance will be 0, right? Hmm. We do this one, right? And when we add, then distance, right? Distance of what? I comma j becomes 0. So I think this is giving us problems because then it always become 1000. So we still get 1000. Hmm. We fail. We do this one. What do I say? This is this condition correct? We remove, right? We get current dot x t0 next. We get this is all true and distance of nx, right? Let's say we are going to the next position. If that becomes 1000 greater than 0 plus 1, right? Then we updated 1 plus distance of current x. Oh, this is correct. Seems to me it's correct. So, what do we have wrong here? So let's see what is our distance after system dot 4 and equals to 0 less than I plus plus, right? We just verify which step we are wrong. So this is a very important step while debugging, right? System dot out dot print. What do we print? We print distance of I comma j, right? Plus this one. Then we move to the new line, right? Let's see what happens. If we get all 1000 here means this, right? This our BFS is wrong somewhere. So, right, this all are 1000, right? This means our BFS is wrong. Yeah, sorry about this. We just updated after we make it 0, right? Later we updated it. So I think that's why we are getting this. Okay, it works now. We don't need this logs. You see this, for example, the first one, right? You see 0, 1, 2, then it becomes 1. For this, the Manhattan distance will be 2, right? 1 plus 1, and so on. Okay. Oh, nice. 71, still good. Okay, let's. This actually does not matter. If your time complexity is optimal, this is fine. Like, it's just the code optimization. It's not always necessary that we need to do this. If the time complexity is fine, then we are good. Okay, so proposed approach is BFS, Dijkstra heap that we use, that is fine. This is multi-source BFS. So I think multi-source BFS is same, right? We initially pushed all the thief nodes. Time complexity is n square log n. That is also right. It's actually n square log of n square, but log of n square log n. So it's n square log n only. Excellent structure. That is fine. So yeah, that's it. Thanks, guys. Thanks.